Lyryx Lab 12, question 3 is very similar to question 2. We also are asked to find the term, but in this case we asked to find number of years and number of months. So we copy down the formula from the formula sheet. So now if we identify that payment is equal 500, P over Y is equal to, as we have here, C over Y is equal for the first question in here, is equal 4. We could see that P over Y is equal to, C over Y is equal 4. They are not equal, therefore we have to use I sub 2. So I sub 2 is going to be equal to 1 plus the nominal rate of 0.09 divided by number of compounding periods per year, which is 4, to the power of number of compounding periods divided by number of payments per year, 4 divided by 2, and minus 1. And at this stage, if we substitute what is given to us, so present value due is 67,720, payment is 500, times I sub 2, we're going to calculate is substitute in the formula, and then we're just solving for n. Once we have n is equal number of years times number of payments per year. Number of payments per year is equal to, so just a question of calculating n and dividing by 2. That gives us number of years and number of months. So at this stage we can use a calculator to do that. So first we're going to calculate I sub 2. So we're going to have a left bracket, 1 plus 0.09 is the nominal rate, 0.09 divided by number of compounding periods per year, which is 4, bracket to the exponent yx, and then bracket 4 divided by 2, 4 divided by 2, well, you can actually divide it without the calculator, but minus 1, and equal. Then we store that in memory 2, like I sub 2. Now if we want to put that second function format and show more decimal places, so let's see like 8 decimal places, enter, and then recall memory 2, we see that the nominal rate is 0.044556, so we can mark that down. Now we can go ahead and calculate n. So we're going to go second function, clear time value of money, 0 place for n because we don't know that. Then interest rate is 9%, so it's 9 I sub y. Second function I sub y, we have 2 payments per year, so we have to override that, enter. Then scroll down, number of compounding periods per year is 4, enter. Then we have 67,770.21 as present value. Then payment is equal 500, change sign as payment. Oh, hold on. And let's just recall whether we have everything there. Payment 500, and recall present value. Yeah, we have everything there. And then 0 for future value, and you have to make sure that you have BGN because it's annuity due, and then compute N. So the N is equal to 20. Now we have 2 payments per year, so 20 divided by 2 payments per year, that gives us 10 years and 0 months. So just divide them by 2, and nothing left there. So 10 years and 0 months is correct answer. Now if you're using TI 8384, first we're going to calculate ISEP2. So left bracket 1 plus 0.09 divided by 4 bracket exponent bracket number of payments, number of compounding periods divided by 2, and then bracket minus 1, and enter, and we have exactly the same value as before, 0.0455065, so we mark that down. Then we go to calculator, financial calculator, TVM solver, and I'm going to put 0 for N, 9 for I, present value is 6770, 6770.21. Then payment is minus 500. Future value is 0. Number of payments per year only 2. Number of compounding periods 4. And then we have BG and begin. It's annuity due. And then we go to scroll all the way to N and press alpha, enter, and we have 20 payments divided by 2 compounding periods per year. It's 2 payments per year, and that gives you also 10 years. Question 4, Lyryx Lab 12. We're going to do the first one. We're asked to find interest rate. Everything else is given, so let's take a look. And we have again annuity due. Present value due is given as 11,204. Number of compounding periods per year is 4. Number of payments per year is 4. So that's going to be annuity due simple because P over Y is equal to C over Y. So we can use this formula in here. And T is equal to 12 years. And payment is equal to 300. If we substitute for that, we're going to have 11,240. So if we did not have a calculator, we would have to do series of iterations. We would basically say the left hand side is 11,204.44. At what nominal rate this is going to be equal to 11,204, so we would have to guess interest nominal rate, calculate I, and then substitute to this right hand side and see whether we have 11,204, and keep on guessing and adjusting until we get left hand side equal right hand side. Using financial calculator situation is much faster. So in this case we're going to enter N is equal to 48. That's 48 payments. For N is 48. Then we'll put 0 for the nominal rate. But then we have to go and put second function I over Y, and we'll have 4 payments per year, so we're going to put 4, enter, and then number of compounding periods is also 4, so we're okay in here. And then we input remaining values, payment, present value, 0 for future value, and then we compute I, and I is equal to 4.5%. If we are using TI-83, so we would put all the values same as before, and then we make sure that it's BGN again, and then we scroll to I, alpha, enter, and again we have 4.5%. So that will be all for those next two questions, so question 3 and 4. Thank you.